SN 1054, July 4th, 1054. On that morning, astronomers in China recorded a new star appearing in the sky bright enough to be visible in full daylight. It remained visible during the day for 23 days and at night for nearly 2 years. Native American rock carvings in the American Southwest are believed to depict it. What those observers were watching was a star dying 6,500 light-years away. The explosion scattered material across space at millions of kilometers per hour. Today, that scattered material is called the Crab Nebula, one of the most studied objects in the sky. At its center sits a pulsar, a rapidly spinning neutron star the size of a city, rotating 30 times per second, the compressed remnant of the star that exploded that July morning. The death was visible to the naked eye across the planet. Nobody at the time knew what they were looking at. But that is not the most unsettling part. This is Eta Carinae, ongoing. Eta Carinae is a star in our own galaxy, roughly 100 to 150 times the mass of our Sun. It should not exist. Stars that massive are at the theoretical upper limit of what gravity and radiation pressure can hold together. In 1843, it produced what astronomers call a great eruption, briefly becoming the second brightest object in the night sky without actually exploding. It expelled material equivalent to 10 solar masses in that single event. The star survived. It is still there. It is currently hidden behind the cloud of gas and dust it ejected in 1843, which glows so brightly it is visible from Earth as the Homunculus Nebula. Eta Carinae is expected to eventually undergo a hypernova, an explosion so energetic it dwarfs a standard supernova. When it does, it will be visible in daylight from Earth. Researchers do not know when. It could be tomorrow. It could be 1,000,000 years from now. Cassiopia A exploded approximately 1680. A massive star in the constellation Cassiopea exploded roughly 11,000 light-years away. The explosion should have been one of the most visible events in the night sky of the late 1600s. There is almost no reliable historical record of anyone seeing it. One possible sighting by the astronomer John Flamsteed in 1680 exists, but it was not recognized as a supernova at the time. The remnant was only discovered in 1947 when radio astronomers mapped it without knowing what they had found. In 1999, the Chandra X-ray telescope imaged it in detail for the first time. At the center is a neutron star with a surface temperature of around 1,000,000 degrees Celsius. A star exploded visibly overhead during recorded human history, and the event was almost entirely missed. The sky was doing something extraordinary, and nobody wrote it down. SN 2006 GY, September 2006. Astronomers detected the brightest supernova ever recorded at that time in a galaxy 238 million light-years away. SN 2006 GY was so luminous it outshone its entire host galaxy for weeks. The explosion was classified as a hypernova, powered by a mechanism called pair instability, where the core of an extremely massive star becomes so hot that gamma rays spontaneously convert into electron-positron pairs, causing a catastrophic pressure drop and triggering a complete explosive disintegration of the star. Nothing is left behind, no neutron star, no black hole. The entire star converts to energy and scattered material. It is the most complete form of stellar death known to physics. The star that produced SN 2006 GY was estimated to be around 150 times the mass of our Sun. It ceased to exist entirely in a single event. The Black Widow Pulsar, PSRB 1957+20, discovered 1988. In 1988, astronomers discovered a pulsar that was slowly consuming its companion star. The pulsar, a rapidly spinning neutron star, was bombarding its companion with intense radiation, gradually evaporating the outer layers of the other star and pulling the material toward itself. The companion had already been reduced to roughly 1/3 the mass of our Sun and was continuing to shrink. Researchers named it the Black Widow Pulsar after the spider that consumes its mate. The pulsar completes 622 rotations per second. It will eventually consume its companion entirely, leaving a solitary pulsar spinning in space with no record of what it destroyed. Since the discovery of PSRB 1957+20, dozens of similar systems have been found. Pulsars consuming their companions appears to be not an exception, but a recurring feature of how certain neutron stars behave. GW 1708 and 17. August 17, 2017. On that morning, LIGO and Virgo detectors registered gravitational waves from two neutron stars merging 130 million light-years away. Unlike the black hole mergers detected previously, this one produced light. Within seconds of the gravitational wave detection, gamma-ray satellites registered a burst from the same location. Over the following days, telescopes across the planet tracked the afterglow. What they observed was a kilonova, an explosion produced specifically by neutron star mergers. The data confirmed something theorists had long suspected but never proven. Heavy elements, gold, platinum, uranium, are not produced inside stars. They are forged in the violence of neutron star collisions. Every piece of gold on Earth was produced in an event like the one detected on August 17, 2017, in a collision that happened before our solar system existed. The merger that made your jewelry occurred before Earth did. The rapidly fading supernova, SN 2018KZR, 2018. In 2018, astronomers detected a supernova that faded faster than any previously recorded, reaching peak brightness and then dimming to near invisibility in just a few days. Standard supernovae take weeks to fade. This one was effectively gone in days. Researchers concluded it was produced by the merger of a white dwarf and a neutron star, a collision between two types of stellar remnants rather than the death of a single living star. The collision stripped material from the white dwarf rapidly and produced an explosion too brief and too hot to match anything in existing catalogs. It represented a new category of stellar death event, one that had been theorized but never directly observed. The physics of what happens when dead stars collide with other dead stars had produced something the models had not fully predicted. V838 Monocerotis. In January 2002, a star 20,000 light-years away suddenly brightened by a factor of nearly 10,000 over a period of weeks, temporarily becoming one of the brightest stars in the galaxy. It then faded. What followed was not a standard dimming. The Hubble Space Telescope imaged a light echo, a pulse of light from the eruption spreading outward through surrounding dust clouds and illuminating them in an expanding shell, creating images that appeared to show material moving outward faster than the speed of light. It was not. It was a geometric effect of light hitting successive layers of dust. But the images were unlike anything Hubble had produced before or since. The cause of the eruption itself remains debated. It was not a standard nova. It was not a supernova. The most accepted explanation is a stellar merger, but the details have not been fully resolved 20 years later. The lone neutron, star RxJ 1856, discovered 1996, is a neutron star roughly 400 light-years from Earth, one of the closest known. When researchers measured its size using Hubble, the numbers did not fit standard neutron star models. It appeared smaller than expected in one measurement set and larger in another, depending on which wavelength was used to observe it. The leading explanation is that the surface is not uniform neutron star matter, but something more exotic, possibly a form of matter called strange quark matter, that forms under the extreme pressures inside a neutron star. If correct, it would represent a class of object distinct from neutron stars entirely, sometimes called a quark star. The existence of quark stars has not been confirmed, remains the strongest candidate. It is 400 light-years away, and we cannot determine with certainty what it is made of. The star that disappeared, N6946-BH1. 2009. In 2009, a massive star in a galaxy 22 million light-years away simply stopped being visible. Not an explosion, not a gradual dimming. It brightened briefly in 2009, suggesting the beginning of a supernova, and then disappeared. Follow-up observations found no supernova remnant, no neutron star, no pulsar. The star was gone. The leading explanation is that it collapsed directly into a black hole without producing a visible explosion, a failed supernova. Instead of detonating outward, the core collapsed so rapidly that the outer layers of the star fell inward before the explosion could propagate outward. A star 25 times the mass of our Sun vanished from the observable universe without the dramatic exit that physics suggested it was entitled to. It simply stopped existing. No announcement, no remnant, just absence. Betelgeuse, the Great Dimming, late 2019 into 2020. In late 2019, Betelgeuse, one of the brightest stars in the night sky and a familiar point in the constellation Orion, began dimming visibly to the naked eye. By February 2020, it had faded to roughly 40% of its normal brightness, the dimmest it had been in recorded modern observation. Astronomers immediately began debating whether it was about to explode. Betelgeuse is a red supergiant nearing the end of its life. A supernova from Betelgeuse would be visible in daylight from Earth for weeks. The dimming turned out to be caused by a massive surface mass ejection, a chunk of the star's outer layer cooling and solidifying into dust that temporarily blocked its light. The star recovered, but the event revealed that Betelgeuse had ejected material equivalent to hundreds of billions of times what our Sun loses in solar wind in a single outburst. It is not dead yet. The uncertainty about when it will be is permanent. The pattern. None of these deaths followed a clean script. A star exploded in 1054 and people carved it into rock without understanding what it was. A star in the 1600s exploded overhead during recorded history, and almost no one noticed. A star in 2009 skipped the explosion entirely and became a black hole in silence. Two dead stars collided in 2017 and forged the gold sitting in vaults and on fingers across this planet. A star in our own galaxy is building toward a hypernova right now, and the only honest answer to when is that nobody knows. Stars do not die on schedules. They do not follow the averages. The universe produces these events continuously, at distances that mean the light arriving today left before humans existed, and the events happening right now will not reach us for thousands of years. The sky is not static. It is a record of violence. We are just reading it slowly.